it's going to be Chris. It's going to be talking about streaming data platforms. Before we get started, just kind of get a pulse of the room. How many people here are using Python, I would say, on a daily basis? How many people are fairly new to Python or just kind of want to learn just in general about Python? Okay. What about streaming? A lot of people will know about streaming. So fairly new to streaming, okay? And what about cloud? This is your cloud. We're going to kind of be touching on all those topics. That's why I asked those questions. And then we'll make this as interactive as possible. So if you got any questions, any slides, but when I go to show code and do just a quick demo, feel free to interrupt me and as valuable as possible. So a little bit about me. I've been in IT for quite a long time. Most of my time spent near Cincinnati, Ohio. And most of my career spent in what I would call traditional business intelligence or data analytics. Recently, I've been doing more of what I would call cloud architecture in the cloud, and I specialize a little bit more on the streaming platform side. So that's a little bit about my background. What I do today is a little bit of that. Sales, I do branch management for a group. Been here in Charlotte for about a year now. I also do hiring, but my most important job, according to the guys at the office, is I'm the one. So that's really the key. So let's talk a little bit about data, right? So there's a lot of data opportunities out there, right? So some of the data opportunities, we need data as fast as possible, right? How many options, like how quickly we get the data, right? Consumers need data from multiple channels. So one of the things that happens a lot is like, well, I need data, but when I get that data, I really need to reshape and look at my business, right? Well, when I get the data, I need that same data, but I want to really just filter out all these other things. I don't really care a very specific thing, right? So there's a lot of custom channels, and not everybody used to go to the Data Warehouse Institute conference all the time. One of the things that over the years that I picked up there, I saw a presentation that talked one of the biggest failures we have as specifically data engineers, but engineers in general, we try to shut off the channels that people get data from. And that is like the biggest mistake we made. You've done all this work when you got this nice data, and you said, but you can only get it through SQL, only through a dashboard, or only through X, right? Whatever X might be. Like, why should you do that? If somebody's comfort space is Excel, let it be Excel. If their comfort space is text fires or writing Python scripts, let them do that, right? Streaming kind of plays into that world. One of the trends too that's happened here in the last few years is that it used to be, maybe back up 7-8 years ago, if you were in the data world, you kind of stayed in that world. You didn't really do a lot of what I would call traditional development work, right? Now that's no longer the case, right? We're being introduced as data professionals into build, deploys, those types of things. That kind of has changed, right? We have SaaS and cloud, right, is prevalent in the ecosystems. We need big data. It always makes me laugh. That's the running joke. If you ever you didn't have a big data problem, you started a big data project, you will afterwards, right? And then you still have the same old process, right? You're never going to get away from batch processing. It's never going to go away, right? Not everything can be real time. Everything makes sense to people. You still have that need for batch. There's several types of streaming platforms out there. There's Amazon Kinesis Firehose. Really, Kinesis. Amazon really breaks it up into 3 specific things like Kinesis Analytics, Kinesis Firehoses. We're going to be doing an example with Kinesis tonight. So we're going to talk about Kinesis, right? There's Apache Kafka, right? So once again, very similar to Kinesis, a lot more mature. Personal opinion, a lot better product than what Kinesis offers, and I'll go over some of those examples today in the code. Then there's Flink and Storm. I'm not as familiar with them. They kind of have kind of niche, sort of things, right? What they can kind of use cases for them, but they are sort of streaming platforms that are better. So far? Going too fast, so I'm going to slow down. So there's a kind of some common string patterns that you'll start seeing out there a lot. Like there's log processing, right? So I need to ship logs. I want to analyze logs somewhere. So you go ahead and put those out to a stream platform, and I'm going to do something, right? You have video or image feeds, right? Those are also streaming things. IoT is very big. I'll expand IoT. I was at AWS reInvent about 2 years ago. And one of the things that they had done was use a streaming platform, analyze the metrics coming off of CloudWatch logs to decide whether or not they needed to turn up or turn down their environments. They were automatically building hardware based off of streams. Kind of taking that to another level. Is everybody familiar with serverless architecture? Okay, so serverless architecture is basically saying you don't really have a server. There is no processing power. Until the data shows up on the stream, and it says, what are you doing with this data? You define some rules in AWS, automatically fires up your environment, does the processing. When that's done, the hardware goes away. It's a challenge architecturally to do that, but once you get that down, you can really scale it to a level. There's a company called LexisNexis. It's not a growing area. It used to be IO years ago. They're running currently, I talked to one of their architecture guys a few months ago, 25,000 concurrent machines service farm. Pretty cool stuff you can do. So I kind of think it kind of takes IoT to like a different level, right? There's IoT in general. There's just batch, right? I got some data and I need to process it. So leave it like that. And now there's a concept of data pipelines or ETL, right? So a lot of us are probably users of LinkedIn. So LinkedIn is the inventor of Kafka. Right? They're the ones that invented Kafka, and they gave it to Apache, the open source of the Apache. So when you think about an event that happens in LinkedIn, all that's handled from Kafka and streaming and data pipelines. Heavily used. I worked for Pinnacle for about 12 years, took about a 3-year hiatus. I worked for Capital One in New York, and then came back to Pinnacle down here in Charlotte. We were down there, we had worked with some of the LinkedIn engineers. They had an environment where they would read database logs and publish data change events out to the world. They just released like their second version of that data engineering trade shows as well. They're doing some really. So it's become a real big part of data pipelines, or what people traditionally refer to as ETL. We had to come up with new words to say the same thing. So here's a sample pattern, right? And I got this off of Snakes and Streams, Python, if I remember correctly. But what's interesting to see here, and I'm going to see if I can find it, right? So over here, what you're seeing is EC2 instances. So it could be Unix or a Windows machine, whatever, right? Some type of client, some type of mobile client. But everybody's pushing data to the same place, right? They're all pushing this into a Kinesis stream. And the thing to kind of see here, that's kind of an important concept, is that you're having a lot of data flow into one area, and then it's flowing out to multiple areas and into multiple destinations. Probably the biggest benefit I personally see with streaming, one of the biggest benefits with streaming, is a write once, read many. So I write it one time to the stream, I can come back and read it with 30 different processes, right? All reading the same data, all being managed of where they're at within that stream reading process. Takes care of it all for you. Kafka does. Kinesis is tricky, but it could still be done. So if you think about it from an IO perspective, You only have to write something once. Now I can read that as many times as I need to all my processes. So you think in the concept of, I need to send out a lot of batch emails based on an event that occurred. I also got to update a microservice data store off of this data that just happened. And then maybe I want to do some analytics, some machine learning. That's one stream, 3 readers, all handling at the time interval. So it's quite a powerful concept. Questions on that? As we kind of dive into the code, and to be honest with you, I try to keep this like as Python focused as possible and not so much streaming. So if you got questions on streaming, just chime in. But the kind of what you need to know, so with the data, when you're dealing with the data stream, this is more geared to like why you would pick Python or what languages are good with streams. So the data is kind of wide varieties, right? So you have to have a tool that can work well. It's got to be something that's a little bit flexible. It's not, the data isn't as rigid, so it's not as well known. Right? So it's like, usually you connect to a database, and you're like, well, it's an integer. You may not know. It can be large, but it still has a record-based concept. The concept is something that knows how to deal well with records. It's good. Structure, you need a language that is easy to manage and troubleshoot. So a lot of the streams are platforms, cloud. Once you start dealing with cloud-based code, I think cloud on a day-to-day basis, you realize that cloud is awesome. So it's not. So you do a lot of like, well, things can go away in the cloud. And I'll just explain some things that happen on Kinesis specifically that like you have to handle. It's a little bit more complex and you get to more use cases. And so you have to have a language that can do some area. So like, what are we processing? So maybe you want to do something with the data that you want to do some machine learning or some analytics on it. Somebody wrote an R module and you want to call that during your streaming process. Maybe you just need to get the data formatted and put it into a data store or something. All these are things that require a language that has a rich sort of support in this community. Also, it's got a lot of modules, it's got a large footprint. It has to be easy to use, right? Because the folks that interact with streams might not be what we would traditionally call the term I don't really, right? So you're writing scripts, like, development, writing entire systems or microservices. We're all developers. It's just how we attack the problem is slightly different. We want a language that isn't so cumbersome to use. That's another. But you still need to have a way to mask complex. Sometimes things are hard, and that's okay. Figure it out. You just have to have a way to maybe hide that from masses so they don't have to deal with the same hard problem. So why Python, right? So it works with almost all data types. I actually don't know if it doesn't work with. I'm sure there probably is one, but I don't personally have one today yet. It's easy to share without lots of effort, so share a module pretty easily, right? Okay. It really has all the modules you need. What I'm getting ready to show you, I put together about 8 to 10 hours beginning to end. I do not do development every day. I still have to go look like, what's that keystroke that those things replaces them? I got to look that up. I'm not a day-to-day developer, so it's a little bit of hunting and pecking. You'll see how easy it is to get. And you can use Python's OO, object-oriented. We're always saying, okay, that's great. So let's get into some actually meat of what we did, right? So we're going to do I'm going to show you a Kinesis example, right? And I'm going to show you code, and we'll demo the code here in a little bit, right? So we're going to show Barth 3 package. So Amazon has something called Botto 3 install. Basically has everything that you need in place with anything that Amazon has all through. Documented. We'll say pretty good. Deal a lot with JSON data and streams. JSON really sort of naturally goes into like a dictionary structure. Nice. We're going to use some class structures, dictionaries, and something that I found out about not too long ago is the yield statement. Has anybody used a yield statement before? I thought that was the coolest thing. And I'm like, oh yeah, cool to me at the time. So that's pretty cool. All right, so let's go ahead and go to the code. There we go. I couldn't see my cursor on here. Hopefully this isn't too bad to look up. All right. So you can tell I'm not a developer because I have my access keys in the All right. So obviously the first thing we got to do is we have to connect, right? So, all right, I got to get a connection to AWS because I want to use something that's in pretty straight. So AWS, if you're not familiar with it, it gives you basically an access key and a secret key, and then you create a session to AWS. Push over here, show you. I wanted to go and I have created two Kinesis stream, Python stream and a Python stream HTML, right? I'm going to go view all of these. And we're just going to be bold. Say, stream. So we're going to delete them. We're doing a live demo now, right? So this is probably a bad idea, but we'll see. We'll see what happens, right? So now, okay, so I've created these Amazon Kinesis, or I don't have Amazon Kinesis streams anymore. So let me go create a data stream. Right? What's a data stream look like? Something called one stream. I have to use the same names. Right? How many shards do I want? So here's like your first sort of streaming concept, right? Shards is just another way of saying partitioning. Right? It's how your data is partitioning in Amazon, right? You can have one, I think the limit is, it might be 500 shards. There's a hard limit. Shards typically equate to your write and read through. Shards you got, there you can read more. Right. It's really important when you get to Amazon Kinesis because they throttle you based on shards. So if you go with one shard and I try to put 5 clients against that one shard, I'm going to get a throughput exception error. The larger you scale out, you got to have the shards. The nice thing about it is I can come in here anytime and say, oh shoot, I'm kind of falling behind. Give me another 15 shards. Number. So it's really that simple. Let's keep it simple. Let's create. It's creating. Well, let's create the other one. Python stream HTML. Now we have the streams, right? Well, what are the things that you want to do with the stream, right? I want to write to the stream. Right? Maybe I might want to get fancies at some point and filter from the stream. Let's hold off on that. Let's try not just do it with writes and reads. We're going to start off with write. Until we do a write, can't read. Let's talk about establish our connection. Now we have a Kinesis interface. So this is where we're first going to start seeing Python, right? So I am not an OO person, right? So I understand it from a fairly high level, but I don't understand it in the weeds. But Python really makes it easy. Go online, you find tutorials, you can be up and running with it, and you really know personal opinion, and it really is fairly straightforward. So we're going to create a Python class, right? We're going to do some initial, we're going to create some what I call class variables, right? So things that are defined at the class level, right? And then we're going to do something where they call init, right? So as soon as I say, give me one of these class objects, these are the things that are going to happen automatically. If I misspeak, one of you gurus out here, please jump in and correct me. Right? So one of the things that we got to do is that, well, every time we want to use this kinesis object or this kinesis class, well, I need to go get my connection. Well, I just wrote my connection object, so I can do that pretty easily right there. That's not so bad. Now I can say, well, I just need a kinesis client. I just need a pointer to a kinesis. Go ahead and give me that. It's fine. Now I want to write to the stream. First time I did this, Google Auto3 Python write to kinesis. They're like, oh, you call this thing called put record. It's pretty straightforward, so let's go ahead and do that. So I went ahead and said, all right, I'm going to put a record. I got a stream name because I got a point somewhere, right? It's going to end up somewhere, and I'm going to use JSON. That's fairly typical when you use environments. I'm going to dump some JSON. Then you got to give it a partition key. Now, real world, you'd have some intelligence to this partition key, or you would say, I don't care. So you might be using identifiers, so it distributes the data, because that's how it's going to decide we have multiple shards. You can get into some processing where if you know the partition, how it was partitioned, you might be able to point to yourself right in the shard. I'll cover that in a second. Kafka kind of handles all this for you because Kafka has a concept called Zookeeper that's kind of managing where you're at, doing what. It's a little more sophisticated. It's also a lot more expensive, especially running locally. It is not easy to Kafka path. It takes a little bit. Not the Python code, the Kafka part. It's a tick, isn't it? I think Jimmy's an expert there, so you can just send all your flow. Yeah. All right.
I'll post Chris's phone number.
That's right. It's a swatch phone number. All right, so we got a write, so we can write now. Well, I was talking with we were talking about like it's really hard to show data examples because of all this textual. Can I come up with some way to like visually do it? And I'm not very creative, right? I kind of always been in the kind of back end systems, so I'm like, I really don't know what to do. So I'm like, I'm just going to cop out. I'm like, I need a stream of data, so I'm just going to get a Twitter. That's what I. So I needed a Twitter read. I've never interfaced with Twitter before. Perspective. Not a huge fan of Twitter, to be honest with you. I'm kind of cesspool of the internet. But so I'm like, you know what? Somebody I know has written a Python module for Twitter. There's actually like 4 or 5. Right? So I chose Python. I thought, cool name, whatever, we'll go. So I had to go set up an app on Twitter, which was basically just fill out a form and saying I want to use it. Right? And I'm like, well, I got to call an API. Well, Python really makes calling APIs really, really easy. In this case, Python kind of wrapped it even further. So I'm going to say, all right, I'm going to write a, I'm going to go basically get a connection to tweets. Then I'm going to say, now I need to get my kinesis. So remember, I created that class. So all I got to do is say, just give me one of those. That handles my connectivity. That handles everything I need to do. So give me one of those. All right, I got one of those. I got to point to a stream where I create this class variable so I can say, this is the stream I'm writing to. Right? Here are the things I want to query. All the things that I love, Python, AWS, I like to learn, I like basketball. Louisville fan, I also like beer. Treat my conversation one, I got very excited. I go across the street. OTF, it's Orange Theory, fitness. Right? I'm Kentucky, so we're forced to like bourbon, we don't have a choice. Right? And then F45 is also like So I'm like, okay, cool. How do I read it? In essence, I call that result. I'm going to go over that list in Python. Pretty easy. Call that results. I'm going to write to two streams. What I found out is this tweets HTML. They actually will convert my tweet right back to HTML for me. I just read all these tweets. Now I'm going to convert it back to HTML. So that was all built in. And I just passed it in the input JSON. Remember in the class, that's all it took. Done. This will write. Won't run it right now. We'll do it. There you go. So now I've written all the things in the stream. Now, I may want to read the stream, right? Well, reading streams, very easy once you do the complex stuff. So reading the stream, literally that's all that is, right? I'm going to go back. I'm going to get my Kinesis, object again. I'm going to say how I'm going to iterate over my stream. There is multiple ways to iterate. Every stream platform has this sort of concept that they're a little different per streaming platform, but I'm either going to start from the very, very beginning. I'm going to start at a point in time, right? Actual time, date time, or I'm going to start at an offset. Kafka uses an offset managed by Zookeeper. Kinesis using an offset, this Kinesis sequence number, choose by that. So you can start at a position within the stream. So if you think about it, I've been gathering tweets for 5 days, and I just want to look at the ones that can 24. I can do that. I can say now my process requires me to look at everything that happened in the last. I can read the stream. Trend Horizon is starting at the stream. That's what I'm telling you. Okay. I built in a filter mechanism, and I'll show you that here in a second. And so in essence, I can start rifling through this code, and it will start reading the stream. I haven't written any data, so if I was to run it, it would return. But it's a way, and I'm just doing a print statement here. That's not what I'm going to show you when we get done. It's just showing you that if you were to write this interface, this Kinesis interface or stream interface in Python, using the, I think, a pretty straightforward Python logic of creating classes and stuff, you can share this, and it makes it pretty easy for anybody. Streams, it's all right there. Like we literally wrote a similar code for back in Cincinnati, and we were calling an API right into a stream, then to another stream, writing that data out to S3, sharing that data with Jupyter servers, pushing data all over the place, all to Python stream was really a small amount of actual code. The error handling code, cloud, that kind of makes things go. Seem a little heavy, but they're really not heavy. It's just the error handling code that you kind of run across as you go. I'll give you all that. When we go back to the Kinesis interface, we had to read a stream. Okay? And I'm going to share all this code out, by the way, so you can all have it. So I'll put it up on GitHub, and it will post that out there so you can have the code, as long as you promise not to laugh. Request. Right? So when you call and get a stream, right, we already talked to the concept about partitions or shards, right? So I have to know how many shards am I working? 2, 10. I got to read each shard. Or I could just read one shard. Say, I know how many shards I got, and I'm going to assign a reader to each shard. Really, however you wanted to do it. In this case, I chose to do it now. If I was to add more shards, this code would automatically just say, oh, a new shard came in, so I got to add that. Nothing overly complex there. So for each shard that I get back, I have to describe a shard. Why is that? And this is a step that's a Kinesis specific step. The reason I use Kinesis as the example, because I think it's a little bit more data one to get up and running, so I thought sharing that code would be more to everybody. But when you read a shard, you have to get what they call a shard iterator. Where am I at iterating through shard? Kinesis does something where it lays down data, and it lays down data in a way that's most advantageous for it to do. So when you set up a Kinesis stream, and I should have pointed this out, you say, how long do I want to retain that data on the stream? You might say 24 hours. You might say a month. It writes the data in such a way where you can easily say, if you said 24 hours, I can lop that data off. The streams are by default 10 logs without doing any work. If you're familiar with like how database logs, kind of my background work, it's really just moving that pointer, which makes that IO extremely efficient. So easy, right? It's a very efficient process. There's an issue with that. It took me a while to understand it. So now that we got a shard iterator, these are just Botto3 calls, by the way, they're all documented. This is documented fairly well. Piece that isn't documented. Show you. So I call get records. That reads my record. I can tell it to read 10,000. That batch and I'll start the system. You go back to a Kinesis stream, I think it will give you some of that information here, right? Actually create. So it's a number of shards, right? That's telling you how many megabytes per second, how many records per second you can read, records per second, how many megabytes per second. If you go above that, it says you have a throughput exception. Chopped off the board. Action goes, right? If you try to put too much data, if you have multiple processes trying to read the same shard, get a connectivity issue. Shard the same stream. All these are exceptions that get thrown. You have an exception module. Funny enough, you can catch them all. Then you got to handle, well, what do I do when that happens? Almost all this logic in here is handling what happens if I get an error thrown. Where do I go? How do I restart? Really all. Okay. There's something here that I want to mention because I don't have this code in here. It's you're doing a presentation on SQLite last thing. That's it. Yeah. And we try to use SQLite for this, and it works if you keep it locally. There is when you're using Kafka, they have the concept of Zookeeper that says, if Jimmy and I both have connections to the Kafka instance, Jimmy's read 10, I read 3, go down, for whatever reason, something goes away, whatever. Jimmy comes back up, start at 10, or he left off, and I'll start. Thesis doesn't really do that for you. You have to code things a very specific way to get that, to get the built-in things. You have to start using fan out and techniques that make it a lot more complicated. And quite frankly, aren't really that important. The other thing is that none of that is foolproof anyway. If anybody's ever used Kafka, right? You've used Kafka, right? You say, there's a possible you could get it. It is not likely, it's probable, and it will happen. If you really care about not processing duplicates, you have to handle it on the side. It can't be handled by you. So what you'll see here, what we did was we said, you know what? We have a JSON. There's a really nice, it's really easy to update what is a dictionary list. Take that sequence number that Kinesis generates, put that in my payload, because I might use that for duplicate checking on the other side. That's what that code is there for. Actually says, I removed checkpoint code because it makes the install a lot heavier. It makes the process a little bit more complicated. This you can just kind of take up and run and go with. Because in live code, you would be running a check against the checkpoint data. So you care about doing the process and hit it. Yep, about 5 minutes. I gotta hurry. That's what you're trying to do. All right, thank you. Anyway, that's it. The nice thing about Python is that I was like, okay, well, what if you wanted to filter? What if I got a stream, and I'm reading the stream, and I want to filter on a value? And I'm going to filter on a key value pair, maybe a list of key value pairs. The dictionary, put the criteria in there, pass it down. care of it for you. That, boy, this little statement right here, right, has a name and I can't remember. Specific technique is basically iterating through the dictionary, doing a match to say, hey, that thing that I told you to filter on, does it exist in this payload that I got? Say yes. This yield statement up here. Okay. So that makes your objects basically an iterable object. Now, as I'm iterating over that stream, I don't have to say read 10 and go away and come back. The yield statement just says, I'm just going to keep reading. Tell me you get out for some reason. Otherwise, I'm just going to sit there, and it makes it more like a constant stream. It makes it really like a iterable. Just it's always so. I will just go right to the demo. Stop talking. So there's a tool called Luma Live. Right? All it does is read streams. Right? Doesn't really connect it to a stream, and it'll let you monitor or filter a stream. It allows you to do ETL. It's a whole platform, but we're just shooting for it. You can kind of visually see things. I'm going to go ahead and so we're going to go into there, and it's looking to fetch incoming events as they come to us. We're going to go ahead and fire up. Here. Just going to start running. Up. Now we got data coming. So I'm now reading the tweets, capturing here on the dashboard. These are all the tweets coming in. So we're doing about 13 per second right now. Short, it's about it, right? Now we got this going. It's cool. So I can say, hey, show me that. This is a tweet. This is all the syntax of a tweet. Right? All the data payload that comes from the API. Now you start thinking about what can I do with that data? Oh, massive. Right? I could write machine learning against that stream and say, go show me things that are looking like I want to see the combination of OTF and workouts too hard, right? Or some combination thereof. All endless, right? So anybody can read that stream. This guy's now reading this stream, right? So it's continuing to do this. Right? Let's go over. Remember, we were writing the 2 stream. We were writing the Python stream. Yeah, so let's go look. Right into that guy. Click. There's same guy. He's streaming the data in. You can see it flowing in. And there's all of our HTML, right? So now it's all more textual. You kind of see, if I was to look at that, right, I would actually see like some HTML text. Well, you go back to it, it's just a JSON document, which is just a dictionary. So you can reference that like you would any other dictionary in Python, right? And then do whatever you wanted to do with it. It just comes streaming through. So, you know, this is kind of a weak visual way to do it, but it was the best way I could come up with when you're doing the data. But in short, right, what I wanted to demonstrate is like there's some complications across Kinesis when you have to deal with errors. But the reality of it is, if you were just writing your own little app and it was just you personally and you were just going after the data, you wouldn't have to deal with all that, right? Because you're dominating the procedure through. You can reach so much data on one shard, it's ridiculous. You have to get pretty high on that. But if you build that like in that class functionality, you can then share that with other developers. You can build on that. It is really pretty easy to do. That literally was roughly about 8 hours. I am definitely not a Python expert. I have to do stuff like everybody else. It's not something I do every day. Say, in fact, I was like today. I was like I want to put something here to iterate over the list so we can see a lot of different things. % sure, excited to do that. Right? Something simple, right? Because it's just like I don't do it every day. It just kind of showed use of Python. This filter right here, so I could do. So one of the things I'm searching for is a Python. I'm just going to start highlighting all the tweets that have Python in it. Or gotten far enough, I could say OTF. Start to find. You see this AWS account, create a couple pieces streams. Right.
can track, visualize pieces, then probably frustrating.
Really, the only reason I did Lumina, I wanted, there's a lot of uses for Lumina, like you can actually do transformations in it. You can do streams. It can do, it's like a whole platform. What I wanted to do was be able to show data streaming in and not have to write like an HTML page to do it, because I'm not a web developer. Yeah, it was really just a way for me to show it. I wanted that to be the lowest hanging fruit possible, because that's not what I do, and that would have taken me like. So,
Thank you.
Any other questions?
How do you compare RabbitMQ in comparison to Penetrate?
So RabbitMQ was awesome. There was like SNS events and SQS. SQS. Right. The difference really to me is that stream gives you that right one stream. You high. To me, that's the difference. Like, you really only need something from once and only one process, and that's your need. You're saying, I want to put something on here, and I want to read it multiple times, and I have some throughput demands, and I got multiple processes that need the same event or the same data. Streaming is.
In RabbitMQ, you can do that, and in fact, you can do it as you can have multiple consumers, and you can split the data in between based on how you set it up.
You read the exact same piece of data though?
It reads the exact, yes.
So you can read, you can write once.
You write once, and you can set it up as, hey, this is one analytics consumer, this is the real-time processing.
They all can read the same
Piece of data. You can exactly send the same way across multiple consumers, but you can also split it up as, hey, if it is starting with, or if it matches particular regular expression, only then stream certain part of the data to this part.
Okay. Yeah, see, I wasn't aware of RabbitMQ. Those queuing system, right? Once you write it, as soon as the consumer reads it, it's destroyed. It's gone.
Right. If you are doing a PostgreSQL queuing, that's how it works.
Okay. Yeah. So other than that, I wouldn't say there wouldn't be a large benefit, other than maybe some of the disaster recovery, the ability to shard out the data, okay, where it will naturally shard everything out and partition it for you without you having to be special. Yeah, RabbitMQ will allow you to write once and put 4 consumers on it, and they can all read the exact same event. Yeah, it's in essence, it's streaming. That is kind of a streaming.
It doesn't do is sharding them. It doesn't do across shards. So the resilience is mostly in memory.
Okay. So the other part is that, yeah, there will be a resilience issue, and there would be a performance. So one of the reasons that you get such great performance out of streams is because of the sharding. And as you get scaling problems, you scale out. That's a simple reason shards. So that's a scaling.
So does it, once you have, say, 5 shards set up, you go and increase to 10 shards, do you have to do anything, or Genesis, does it take care of?
Takes care of it all. That's what this code is doing right here. I say my shard list. That's why I got to constantly refresh that, because at any point in time, somebody can change the number of shards in the background, and that's how. So if it said if you were at 1 shard, went to 20, I'm iterating over shards and trying to read them like round robin. So what we did in a real life project, we had this reading round robin, and we just deployed as many EC2 instances as we wanted. I would constantly be reading the data across multiple shards. So you might fire up 10 unique systems, all reading the same stream, all round robining through the shards. That's how we've got there's multiple ways to do it. That's just does that make sense? I'm sure I'm clear. Awesome. Thanks a lot.
So next up, is going to present Python manufacturing.
want to thank everybody for coming out. And like Jimmy said, I'm going to be talking about Python and manufacturing. And I want to put it out there, like Chris, if anybody has any questions through the presentation, or if I'm going too fast, or even if you just want a little bit more detail that I'm giving on a particular subject, raise your hand or speak out and let me know. I know most of you probably aren't living in the same world that I am, so you know, I may, in my mind, make assumptions about prior knowledge that you have that you don't know. First thing I want to talk about is who I am. I'm a husband, a proud father of 2 wonderful kids, musician in my free time, which I don't typically have anymore. Iowa State alum and an avid Cyclone fan. And I'm also a product development engineer at a company called GK. Who aren't I? I'm not a developer. I'm not a coder. I'm not a data scientist. I am a guy that works in an environment with lots of data that uses. I also don't live in Charlotte, so speaking at a Charlotte Devs event is probably a little bit posturing, but I think it'll be okay. When you take a closer look, engineers are problem solvers. I think most of the people in this room are either currently engineers or they're aspiring to be engineers. And really, programming is just a tool to help us solve problems. It's not what we do, it's how we do what we're trying to do, how we solve the problems that we're trying to solve. So what do we do, or what do we do specifically at GK? So the division I work in is a driveline division. We make driveline assemblies components for vehicle manufacturers such as GM, Ford, Chrysler, Fiat, BMW, Maserati, and there's a gamut more. And you can think of driveline as basically how the torque or how the power gets from the source of the power, like an electric motor or an internal combustion engine, out to the wheels. Specifically at the facility I work at, we build PQs and RDMs, which I circled in the context of the vehicle. And I don't know if anyone can quite visualize where this is in the vehicle, but your engine would typically sit somewhere right here. Your transmission, these are your front tires and your back. So we focus on the assemblies that basically change the direction of the power. So your transmission and engine are typically in this orientation. So you have to turn the power to send it to the back wheels. And then once it gets to the back wheels, you have to turn the power out to the rear wheels. And we do a wide variety of different parts. You know, there's a very simple version, which is just a ring and pinion housing cover, and all it does is actually turn the power. But then we also have versions that have disconnect clutches and half shaft disconnect clutches, which I'll go a little bit into that just because it's relevant to the work that I do. So a half shaft disconnect goes between that RDM and your half shafts, so your CBJ joints. And what that does in our case is you can command a particular torque value and send different torque levels either to both wheels in the case of our single clutch, or to each wheel individually in the case of our twin stir clutches. And it has a lot of performance or a lot of functional advantages. One being that if you have a disconnect, you can disconnect your prop shaft, disconnect your half shafts, and now you have all this rotating mass that's no longer turning, which improves your fuel efficiency. You can also use it to improve traction in low traction conditions such as ice, snow, rain. The car is actually smart enough to figure out which of my tires doesn't have enough traction, and it will transfer torque to the other tires. And then a third potential improvement is there are some cases where they can program the ECU to improve performance. So if you're going around the corner, you can actually transfer more torque to the outer wheel to help push the car around the corner. Or in the case of the Focus RS, you can actually over torque the rear wheels, which creates kind of a rear skating condition, which is a drift mode. So it allows your rear tires to break free and to slide around. So, you know, depending on how it's programmed and how the driveline is set up between the front and the back, you can actually have a lot of different vehicle dynamics based on having those two clutches in the rear driveline. Everybody good?
You test drive them?
No, I almost got a chance to take the Maserati in our garage to Tennessee for one of my work trips, but someone else had already taken it because typically they don't let people drive the test vehicles unless they're trying to put miles on them. So almost. And the focus area specifically, we only have occasionally when we really need it, so I've never had enough. Mostly just the Acadias, the Equinox, the Escape. I get to drive those. And I guess that's a good point. It's the parts that we build at our facility are for four-wheel drive vehicles, typically a small to mid-range SUV like the Acadia, the Equinox, Ford Escape, the Jeep, the Renegade. So kind of small to mid-size SUVs, four-wheel drive. There's a good chance that some of you probably have some of our equipment in your car. So the role I have is a product development engineer, and I'm responsible specifically for the clutch actuation system. So if we have any new product, I work with our systems team in Lomar, Germany, and our applications team in Michigan to develop that new product. I work to improve existing systems, primarily for VA, VE activities, trying to make things either cheaper component-wise or cheaper to produce. And then I also work with our manufacturing and quality engineers to troubleshoot and improve existing processes. So where does Python come into play during all this? Pretty simple answer, it's data. And maybe not as much data as you might see on, some high volume websites, but, we're using Excel, lots of data. So I'm going to try to play a video for you and do my best to try to, whoa.
Yeah, something's flickering.
Turn here. So has it been doing that the whole time?
No, just like a minute ago. Yeah.
Well, we can go full chain on
Yeah,
this video. We'll give you a little bit of a break if you're feeling tense. So I'm gonna start this video. It's one station on one of our assembly lines. I'm gonna do my best to try to quickly point out where potential sources of data are throughout this process, but it's pretty fast and more than likely gonna miss some things. So every step in the process has a Boolean bit saying the step was completed, so the okay. Now, to a SQL database. And on this line in particular, we also have a FTP that stores the 2D data from the press operations. That's one station. So just in this view, we have, I think it was a dozen press operations. And here's an example of what that 2D data looks like. Not on that particular application, but you can see it's a distance on your x-axis, force on your y-axis. And then we typically will draw boxes around different parts of those curves to try to analyze for failures. We do a lot of gauging operations, both static, like a shim measurement where it's just a single data point, but also dynamic measurements where we might be turning a bearing assembly and taking a distance measurement while we're turning. Torque operations, which are, yes.
I was saying, you want to try disconnecting and reconnecting.
Oh, yeah. We're still jittering, aren't we?
Sorry. All right, oh, you're disconnected, right? Or
Yes, I'm disconnected. Anybody have any questions why it's rebooting? Yes.
Maybe you'll answer this, but where do you store all that data? Have your own servers, or do you rely on?
So we don't use any cloud-based services. Everything that we have is, I think you would consider it on-prem, but we have servers at our Auburn Hills facility that store all the quality data. And basically all data is stored on those servers. And the majority of our production data is on a SQL server. And but like I said, we have other data sources like those 2D press cores. Traditionally, we haven't stored those just because there hasn't been a good mechanism to store them. But on the newer equipment, partially because of customer requirements, we are storing that data. And that creates some other challenges, but I'm not going to go into it too deep here. If you want to
I'm not quite sure what's going on there, sorry.
focus a couple feet down. I don't think I have anything super important up in that section. So we get torque operations are similar to press operations. You have a torque versus angle curve, but also one-dimensional data for final torque values. And torques are basically how tight you're tightening a bolt. And we do a lot of that. And in leak test operations, so pressure decay leak test, you have two-dimensional data with pressure decay over time, as well as the final leak rate output. And then we do a lot of mesh performance, functional tests operations. So how well the gears are meshing, noise, vibration, harshness testing. The thing I'm focused on most often is clutch functional testing. So making sure the clutch is performing as we expect it to. So this picture only captures just a small piece of our site. It's 1 of 4 halls, 2 of 16 assembly lines, 0 of 6 gear set welders, and 1 of 2 plants. So even though you can see all these different data sources in one spot, it's just a small piece of all the things that we're doing. So I'm going to go over a couple different use cases. The first use case is to try to illustrate how I was able to improve the efficiency of some of my work using Python. And then the second use case will be kind of diving into where we were able to get a little bit more insight on our data that maybe wasn't impossible using the tools we previously used, but was pretty difficult to do. So on a weekly basis, I analyze clutch and end-of-line failures to try to understand why we were failing to drive to root cause and reduce throughput and scrap costs. So a big thing in any business is try to reduce costs. And one of the most common ways that you bleed money in a production facility is scrap and failures that cause throughput issues. So every time you fail, that's one unit that's not being sold and sent out the door. So it's got a heavy focus, and I specifically focus on the clutch end-of-line testing since I've got the responsibility for clutch actuation systems. Ooh. My original process involved using Excel, and our DBA had set up connections with spreadsheets that we could refresh and do some simple query editing. So I'd pull the data in on one tab, and then I would use that to pull data in another tab and try to identify specifically units that had failed, and a particular parameter called the customer trace code, which is how the data is stored on the end-of-line machines, which I could rant about that for an entire 25 minutes, so I won't go into that. And then I would walk out to the machines, physically go to each of the 7 machines. And originally what I would do is either search for those units on the machine, or I would copy, the 7,000 CSV files over and search for them on my computer. Tell your face, it was painful. And then once I had the CSV files available, I used a tool called Famos, which is actually a pretty good tool for doing this type of analysis. You can pretty quickly stack different datums on top of each other, do some frequency analysis, FFT analysis and stuff like that. But even with that, and even though it has some scripting ability, trying to do a mass analysis of this visual data was painful, because you could get everything in there, but then you had to kind of click the datums that you want to display and then graph them and do all that type of stuff. So it was still much better than using Excel to display the data, but still a fairly manual process. So now I will go over my current iteration of what I am doing. This is actually Flux 2, so it's not necessarily the most recent version. So I use a tool, I use Jupyter. As if you're familiar with Jupyter, you could probably pick that up right away. And then for this type of analysis, I'm using a tool called PaperMill, and that's mostly to try to keep segregation of the different chunks of analysis that I'm doing. So that way I can kind of have an ongoing record of the analysis as I'm doing it. So I'm not rewriting the same thing over and over again. So this particular notebook, all it's really doing is determining, based on a couple parameters, how I want to do my analysis. And really, you boil it down as, do I want to pull new data, and what are my start and end dates for the analysis? So I have it set up right now to be static start and end dates so that I know it'll work. And kick that off, and then we should get an exception. So what's going on in the other notebook that's being executed is it's pulling the same data from the same data sources. So I used a modified SQL query to get just the failed units. And then I ended up using that data in pandas to generate a new SQL query to get the customer trace codes. And then from there, I update an Excel file with the particular trace codes that I need. And then there's a VBA macro that I'm running, you'll get to see that I take out to the machines and actually pull the specific files off the machine that I need. So the reason that we had an exception, there's probably a better way to do this, is no files were loaded. So essentially, the data that I have to physically go walk out to the machine and get isn't currently available on this machine. So that's where I would go and copy this file mover over to a jump drive. And what this file mover does is it takes a list of files that were generated, and Python already updated this Excel document to do that. And then when I'm plugged into the machine, it has the path for those files within the macro. And all I have to do is click copy, and it'll generate a folder on the same file level, or those generate a folder on the same level as that Excel file with all the files from that machine. So once I get back to my desk, take that folder. Oh, where's 12%? It's you. Double check to make sure they're in there. I will copy that and put it in my end of line files folder, which seems silly now, but typically that would be on the jump drive. I'd copy it to a shared location server. And then if we go back to Jupyter and run that notebook again, it should pass. But instead of running the notebook that executes via Papermill, I'm actually going to go to the notebook that was generated by Papermill and execute that instead. So that way you can see the visualizations. Because one thing I've run into that's a little bit funky, and there may be a way to fix it, is I use Plotly for my visualizations. And when I execute a notebook using Plotly, it creates the space as if it rendered, but it doesn't render. So I always end up having to rerun those cells anyway. So typically I'll just rerun them anyway. So we are here. There it was. I'll go ahead and restart and run this, and we should see graphs start to populate at the bottom of the screen. So while that's loading, did anybody have any questions or want me to go into any more detail as far as, yes?
So when you talk about failures, are you talking about units that you're producing that are failing, like a quality assurance, or are you talking about, okay, so it's not necessarily a unit that made it out into the field and then had a failure and then made it back. It might be something that failed beforehand.
For this particular analysis, it's trying to understand what's creating the throughput type issues in our process.
Okay.
There may be situations where something does get out to a customer or leaves our dock and is sitting out in the warehouse. And there are definitely cases where we have to retroactively look at that data and try to understand what do we need to try to call back.
Okay.
And, you know, since I've been at that company, we haven't had any recalls, but typically when you have a recall, it's exactly this: something wasn't detected or there wasn't a quality assurance control put into place, and there was an escapement that got all the way to the customer. And depending on any safety related escapement has to be a recall. But companies like Toyota are also really good about other escapements or other quality issues that are found. They'll still put in a recall. You know, my wife's dash got swapped out because it's cracking, which obviously is not a safety related issue, but Toyota's really concerned about that.
When you see this data start to I guess create trends, does it generally point towards like one of the robotic systems that you showed us in the video, where one of them is just maybe towards the end of its life or just isn't performing as well as the other ones, or what does it normally point to in terms of root cause, or is it hard to say?
So for the particular type of data, I can show you the data too. It might help illustrate. I'm really focused on one. Oh, I have the file open. That's why. Sorry. Real-time debugging by David Smith. I'm focused on one process in particular, which is the clutch end of line. And there are definitely certain processes like bolt torquing that you have a very representative one-dimensional point like final torque that if you see a final torque start to drift, you can use that and say, maybe my tool is going out of calibration, or maybe the housings are starting to go out of specification, or maybe my bolts are a little bit soft, which those can be really good indicators. But a lot of times for that type of analysis or that type of trend identification, they'll use SPC tools, which are basically control charts, and there's a different rule set up around those control charts to try to throw a flag and say, hey, something's not working. And we can talk about it a little bit more afterwards, because I think there's a lot of opportunity with machine learning in this field specifically for trend analysis and proactive failure identification. So, but we reel myself in. No, don't go too crazy. So, there we go. Okay, so these are an example of two field curves, and I intentionally kind of baited this to show the failed curve. So this is where there's another opportunity for me, and I'll talk about it a little bit later. But based off of my experience, you can see that this is displaying multiple runs on the same unit, and it's displaying the left-hand torque and the right-hand torque that's being measured on that clutch end of line machine. So I can look at this and I can say, for these two torque steps here, they should be at 1,000 plus or minus some threshold, at 300 plus or minus some threshold. And if you look, this 300 newton meter step is over 400 newton meters, which I know from experience and having done about a dozen teardowns, that indicates a valve assembly issue in our clutch assembly area. You can actually somehow get the small spring caught in there sideways, and every part that we've ever torn down that has this behavior has been a sideways spring. So I can look at that and classify it as a sideways spring. We can go ahead and do that over here. And the way I do it is I have the actual serial number, which I already have it here, so I don't have to copy, and then the value in that dictionary is sideways spring. And then go back here, we'll look at the second unit, which obviously looks very, very different. This is bad. You can see we have very heavy oscillation, specifically in the high torque step. And this is a behavior that we ended up dubbing as sawtooth. And it's because, not quite as obvious in this one, but it typically has a very sawtooth-like behavior. And this is caused by high mechanical resistance in the pump and motor that actually basically applies the pressure on the piston to actuate the pump. So if you have a high breakaway torque on your actuator, your ECU ends up not being able to properly compensate for it, so it overshoots, comes down, overshoots, comes down, overshoots, comes down, overshoots, comes down. So that's what causes that. So I can look at that, pretty quickly identify it with our alias sawtooth. So
Is that because there's PID being applied? Is that what's?
I am not as strong in the algorithm driving the clutch as I should be, because I know bits and pieces of it, because it's a fairly, it approximates just clutch temperature, it approximates, it looks at the motor speed, it looks at your matching factors, which are kind of a calibration factor, and it uses all these different things and determines how I need to command the different components to get within 10% of whatever the vehicle wants that torque to be. As far as the actual control structure, I'm not 100% sure what's going on with that. I know specifically this behavior happened because we had a small sample of parts that were used to develop the algorithm that the actuators had been run like crazy. Like, they're very well run in, loose, good running actuators. And now that we're in production, we're starting to see actuators from the supplier that aren't optimal. They're, whatever components are contributing to the pumping tighter, they will get down towards one end of that range that they're allowed to be in. So specifically, starting the motor is what causes the issue. So the amount of force for that motor, which is only capable of about 1 newton meter, to overcome that pump, kind of creates that overshoot condition. Then its inability to compensate. And they've made an update to the algorithm to be able to compensate for it. But unfortunately, in current production, this is a GM platform. They're very risk adverse when it comes to software changes, which is probably good. You guys know how bad that can be. And now put that in a safety critical part of your vehicle. more than likely we have to kind of deal with the bleeding on this particular issue. So, because we don't have really the system designers were the ones at fault here. But coming back here, that one was also in there as a key and a value. I'm going to skip that section because we already run that cell. And if I run these last couple cells, what it does is it generates a folder of files. In this last notebook, there's not really a whole lot interesting going in there. It's just generating some Excel files and it's generating a couple HTML files. And that's really kind of the useful piece of this analysis after that. So if I go into the folder here, you should see them start to come in. Units contain is an Excel file that contains, units contain is exactly that. It's units that we want the quality engineers to go out there, get their hands around and make sure that there's no possibility of them getting out to our customer. So they have the information about what failed, which line it came off of, the partial trace code, clutch identification numbers, which are really the only permanent marking on the part that they can identify them with. And then we also output an HTML file per unit that if they're curious about what's wrong with the unit specifically, they can double click this HTML. And I use Plotly to generate a standalone HTML file so they can look at the behavior. And it's got the same kind of, zoomability, pinnability, hoverability that Plotly would have in the notebook too. So it gives them kind of a nice visualization that I can send via email, or typically I'll drop that whole folder in a shared location. Of course, the couple of quality engineers that are using notebooks, they can open it up themselves and look at the analysis, or if they have Chrome or any browser, they can open up this file and look at the behavior there. So that dramatically improved the efficiency of my analysis because I automated a lot of the bits that I was doing by hand, but also the visualization, being able to quickly look at all the different visualizations made things much faster than using Thomos. And I have a better version of this I'm working on in Dash, where I display a single curve at a time, and then I actually have an input field that I type in the classification, and then once I save it, it dumps it. But I didn't have it quite to where it was generating all this information off that application yet. So maybe another time. But, okay, let's look at the second use case. How am I doing for time, Jimmy?
5 minutes?
That's not. So the second use case is we needed to determine updated limits on a particular parameter called oscillation. So, okay, should have ran it ahead of time because you're not really anything that dynamic stuff. So the way our process is currently set up, there's a lot of data that isn't sent to the quality database. So the only way to really try to understand how these parameters should be set is to retroactively calculate the parameters the same way that the machine is doing. So the way the machine is calculating this oscillation parameter might be actually easier to show you here, is it finds a particular torque set that you want to do the oscillation analysis on. From the end of the torque command, it goes 50 milliseconds back. And then from there, it looks another 500 milliseconds back. So half a second, 50 milliseconds offset from the end. And then it takes that raw torque data, does a line of best fit, and then it looks at the distance relative to that line of best fit of the raw torque signal. And if those min and max values don't exceed whatever threshold you set, it's past oscillation. And just to kind of give you a sense of what that means is if you're in a vehicle with high oscillation and the clutches kick on, specifically in a torque range that, a higher torque range, you could feel a shudder or a vibration coming from the back of your car. So that's why we have these parameters in there to try to filter them out so that you don't get that feedback back to your vehicle. You don't want your car to sound like a whale. Go back here and see if it's finished. So here's a plot of what I was talking about. You have your raw torque signal at that particular location. You got a line of best fit, and then this calculation that finds the distance from the line of best fit to the data point. And the way they're doing it on the machine is they're actually just calculating it in the y-axis. They're not doing it normal to the line of best fit, which I feel is kind of wrong, but the difference is negligible. So you typically don't have that high of a slope. So that's a visualization of what we calculated. And I did it on a much smaller sample of files here, but I was able to do it across about 3,000 files from production. And I randomized those samples. So I actually collected, there's about 300,000 files that I looked at, and I randomly collected about 3,000 files out of that sample. And then I did a statistical analysis based on that calculation, which is down here. So, just basic statistics, mean, standard deviation. We typically will set our parameters to 6 sigma, which is plus or minus 3 deviations in each direction. There are exceptions to that, but this Python basically allowed me to get insight to data that, like I said, technically probably would have been possible in Excel, would have been really, really difficult to do. And really anything graphical, I have a lot of trouble trying to do in VBA. Excel and Python makes it really, really easy. So that's another example of using Python to get better insight on my data. And let's go back here so I can finish up the last couple slides. So I'll talk about my next steps. I want to further improve the efficiency with the failure analysis, and that was the dash I'm talking about. Basically be able to go through and categorize the curves in a much simpler way, not copy and pasting and updating a dictionary and doing all that. I want to make the machine do my job. So I've been working with a couple guys at the meetups, Richard and Tony. I don't here, but they both have done they either have a lot of experience with neural nets machine learning, or in the case of Richard, he's done specifically machine learning on 2D type data like this. So I'm going to work with them and see if I can't, that visual classification I'm doing for sawtooth and cyclic spring, see if I can't have the computer classify it. And what I'm doing with this type of analysis is I'm building up a learning set. So I want to develop better tooling for analysis. So a really simple wrapper around our SQL database, a really simple wrapper around this 2D data. And that should lead into training other manufacturing and quality engineers to use Python and Jupyter. Because to me, once you kind of get a handle on it, so much better than Excel. I can't stand when I have to use Excel anymore because A, it runs horrible on my machine because it's a 32-bit Excel on my, what computers aren't 32-bit anymore, or aren't 64-bit, but like I said, there's just so many advantages to using Python for data analysis over Excel. And I think people are a little bit scared of it because it's programming. Well, it is programming, but I think if you simplify it enough, it can make it accessible to people that maybe aren't quite as comfortable with programming. And then I want to use that to train kids on programming, and specifically kids that are in schools that don't necessarily offer an after-school program, or maybe can't afford an after-school program. Because there's a lot of great programs that teach kids programming, but it's $150 for 6 weeks. I know a lot of parents that can't afford that, so I would do everything I could to try to make it free or as affordable as possible, just to kind of open up those opportunities for other people. And I figure if I can train engineers how to program, I can probably teach kids how to program, because kids are much better learners than engineers. So.
With Minecraft.
So your next steps are go solve some problems in Python or whatever your language of choice is. So if you're new, if you're wanting to get into Python, find something you need to do and just go do it. Because it may not be the case for everybody, but that's how I learned. I had this thing I wanted to do, lots of Google, lots of Stack Overflow, and just pound your way through it. So, yes?
Did you convince them to use Python, or you just kind of did it?
So if you don't install it globally on your system, you don't have to tell anybody. Anaconda, the Python interpreter, Anaconda, most things. The only thing I convinced one of our IT guys to plug in his magic admin password for was Git. But a lot of the development tools don't require administrative rights to install. So I've been able to do a surprising amount without telling anybody. And they all know I do it. The guy that manages the database sees all these requests coming from me that he knows aren't me. I'm not going to make 200 requests in 4 seconds, but so yeah, he's a lot of them are well aware of what's going on, but it's not necessarily a officially sanctioned thing. But that being said, our company does have a Jupyter hub that some of the European engineers are using for big data analysis. But there's kind of some challenges with that in the particular context that I'm using Python. Specifically, local and our file server based storage of the CSV files. I haven't found a good workaround to get those into the hub, but also I make a lot of crappy tooling that I use to just, I'll just throw out a function so I don't have to write the same function in the notebook over and over again. And I don't have to go begging and pleading to update that stuff in that hub every time, I make a change or something. So I mostly work local on my machine.
Which part, you usually use the CSV file, right?
That is what the,
Yeah.
the machine is generating CSV files. There are a couple other machines that generate XLSX and XLSB, which is probably one of the few formats in Python that's kind of a pain in the ass to read because Pandas doesn't do it natively. I had to create my own library to do it. But some of the data is contained in an Excel file, but most of the raw kind of datum streams for that particular test is in CSV. And that is part of what I'm trying to push towards, both for data integrity as well as, me not having to get off my big fat butt and walk out the machines is there is a proposal to do a SQL Express server locally on the machine and then on some frequency going in there and pull that data off into our main SQL database, which will make it much easier for me because I can query the data directly in the database and not have to walk out to the machines. But also, you're not storing hundreds of thousands of files on a disk that has no backup or there's not really a good mechanism for robust storage of those files. So we have a red hard drive, a black hard drive, and a green hard drive, and I'm sure we'll probably have a blue and yellow hard drive at some point storing those files. That can potentially be a big problem because our record retention requirement for our customers is 10 years. So it's a good chance some of those won't survive the whole 10 years.
So kind of tagging along the SQL, that database that you were just talking about, being like able to push or pull from the server that you have. Like, have you thought of potentially using like Apache Airflow or something to kind of schedule some of these functions and collections and pulls?
I have not. We have one guy that kind of handles all of the SQL database stuff, and he's a little bit old school. All the functions and he's got a program that handles the TCP/IP telegrams coming off the PLCs, and looks at the header, identifies the type of telegram, knows how to chunk it into pieces, and then he throws it in the SQL database. But he does all of that in Delphi. So if I were able to explain the benefits of something like that to him, it maybe convince him, because I don't think he's completely opposed to learning some new technologies, but I wouldn't even know where to begin to explain to him. I'm not necessarily the technical lead at the company. I'm really more of the guy that uses the server to get the data I need to do my analysis for my mechanical engineering stuff. But it was called the Airflow.
Yeah, Apache Airflow.
Apache
It's,
Airflow.
it's like a workflow scheduler, so you can have paths of logic. So you pull the data, you action on it,
Okay. That might be something I could look at, maybe implementing on a lower level too, just to kind of, instead of me going in and executing these, I can just have it automatically execute. So
There are alternatives to Apache Airflow too, that are not that heavyweight, but as you look through Airflow alternatives, you find them.
Okay.
Have you been to Davidson Machine Learning Group? It
No.
should be very close to you.
yeah, I only just recently realized that was a thing. Because part of the reason I started coming to the Charlotte Python meetup was I didn't realize there was anything further north. So
It's very active group, and they meet for study groups for machine learning almost every other week,
nice.
and they do projects together. That would be a great place for you and close by.
Yeah, no, that'd be fantastic. Where I live in Mooresville, I'm actually only like 2 miles from downtown Davidson. So. Yes.
I was gonna say what resonated with me was like you just kind of broke down like everything into small tasks and just tackled, like you said, you slogged through, just did one thing at a time. And that's, before you know it, like a year later, it's completely different. And you're not gonna get to everything at once, boil the ocean, but you're just tackling the next, sometimes it's like low hanging fruit, and sometimes it's like, okay, this is worth it if I tackle this one. So another cool thing is, like, I'm in data science, but a cool thing is it's just capturing all that data and you're labeling it. So when you're in a position to do some of this stuff, you're gonna be in a good spot, to map it all together and everything. So that's kind of cool.
Once I finally finish my neural net book, just nail it
Oh,
down.
and so there's like state of the art stuff, but also just good old school, some of this stuff I can think of is like, just if you just Google, like outlier detection, there's things like, isolation forests and stuff that are kind of easy to implement. And you might be surprised sometimes just like basic stuff can find things that you wouldn't think normally.
Well, and I can't remember the exact model and algorithms we use, but one of my coworkers in Germany, that's essentially me, but sitting in the actual systems engineering office. He's a younger guy that uses Python too. He actually did develop a fairly simple machine learning model just based off the one-dimensional data in the quality database. And I think we were able to get it to about 80% accurate for identifying specifically sawtooth defects. So we got partway there on one particular defect, but the curves I showed you were really just two of the datums that we see. There's also, those are your torque measurements, but then you have motor current, motor speed, valve current on both the left and the right-hand side, rig speed. There's so many different parameters, and typically I can look at the torque behavior and say like, okay, I know what this is, but there are times where I have to stop and add a couple of the other datums in to try to figure out what the heck is going on here. And that's where, we made that model specifically to find out one type of behavior, but it gets a little bit more complicated when you consider like just that chunk of data is not necessarily going to tell you the whole story about what's going on in the system. In fact, I got my butt kicked at work today, not literally, but just mentally, because there's a set of units that failed for something. I still don't know what's wrong. We tore completely apart. No idea what's wrong. So, even with a trained eye and having all the data in front of me, it can still be challenging to figure out. But, I think there's definitely an opportunity there. And at least initially, I would treat it more like it would fill in the blank for me, and then I would validate the blank or validate the data that it fills in. So, and at some point, once we get some confidence in the output, I actually want to try to make a tool that we can put on the shop floor. So when that unit rolls around to the rework station from after the failure, the operator scans it, it'll give them, this is the behavior that I think it is based on my machine brain. And the last 1,000 parts, or we don't that many, but the last 100 parts that had this particular behavior only pass 5% of the time. It allows them to make a better decision about whether or not they should retry that process or not, because these are very dynamic systems and you can legitimately have a good run after a bad run, even though it's a good part. It's, it might be that the clutch required a little more greening or something like that, but something like that would, have a cost impact because we're not wasting cycles on parts that will never pass. Or in some cases, they run 12 times, which is not supposed to happen, but they do. And then it happens to be just good enough once to get out the door. So I've seen that before too. So there's, there's a lot of opportunity.
David, I'm sorry, we're running like 20 minutes over.
Oh, no, my bad.
All right, sorry to interrupt.
Was it just me or were Chris and I tag teaming that over?
Yeah, it was tag teaming. So I gave you both like extra 10 minutes. So.
Okay. No, I understand. Thanks, guys. And I guess just real quick, if you want to get a hold of me, I'm on Twitter, and then I also frequent the Charlotte Dev Slack, and I'm on Coding Blocks Slack. It's a great podcast if you're familiar. And then my email, david.d.smith@gmail.com, and I'll try to figure out a way to share these slides. I don't think there's anything too proprietary on them that I could share them with the group. So the notebooks I don't think I can share, but I can definitely share the slides. So.
Yeah, just send them to me and I'll post them up on the Meetup page.
Sounds good.
Cool.
Thank you.
Thank you, David. Thank you very much for coming out. Thank you to David, Chris, Richard, Emily. Shameless plug really quick. We have a Python office hours, February 9th. And basically, just bring in your questions, whether you're a beginner, expert, just come and we'll talk about code. Other than that, thank you for your patience that we're running a little bit late, and we are going to go have some drinks at Yancey Road Brewery. So if you want to come join us, feel free. What's that? Yeah, it says like right over here or something. Yeah, so great. Thank you very much, guys. Thank you.